Super happy that you're here. Thanks for joining us. If you've been following along the series, we've talked to investors, founders, we've talked to lawyers, and now tech, which is a really huge part of blockchain. So to kick it off, I'm just going to ask everyone on the panel to introduce themselves and tell you a bit about what they're working on.
Can we turn the volume down a little? It's really loud.
Blaring in Ronan's ear. Hello, mic check. Hi, my name is Zane Witherspoon, also known sometimes as DJ ETH Ledger. I am the CTO.
You just played at South by Southwest.
Yeah, actually, a couple nights ago. Yeah. I'm the CTO of Dispatch Labs, a new exciting blockchain protocol company building one of the new next-gen blockchains, as well as being a founding partner at the Bureau, sort of a full services blockchain ecosystem. Should we go into depth a little bit about our background? Yeah, okay, cool. So I was in network security mostly before getting into blockchain in 2016. I interned at Raytheon as well as did DDoS mitigation with NexusGuard. And I made my way into the Ethereum community via the SF Ethereum meetup, which I still help co-organize today. And I take a lot of inspiration from the developer community that Ethereum has been able to establish. And their introduction of smart contracts into the whole blockchain ecosystem has really, really accelerated the pace that we're seeing dApp development today. So that's sort of the basis for what we're doing with Dispatch Labs, sort of building upon and trying to push forward. And I think it's really, really cool to be able to stand on the cutting edge of where technology is, and then to do what we can as technologists to just like push it a little bit further. Cool. Thanks.
Hi, my name is Monica Quaintance. I am the lead engineer at a blockchain startup, a next-gen blockchain startup, as apparently we're calling them now. It's called Kadena, and we have a scalable proof-of-work solution and a smart contract language that is a Lisp, which means you no longer have to write Solidity ever again. That's the goal. Yeah. If you've ever worked in Solidity, you should be clapping right now. So we are hopefully rolling out our platform by the end of the year, and there's a lot going on right now with that, so we can talk about that later. I was a data engineer for 3 years, also doing some systemsy things, and before that, I was a quant at the SEC, and before that, I was an investment banker. So lots of different perspectives from the New York finance-based regulatory perspective. We can also talk about that.
Thank you. Hi, my name is John. I'm one of the co-founders at a company called Enigma. We're doing so basically what we think is privacy is a huge issue on blockchains, and blockchains as is will never get to a meaningful let's say use if you cannot move beyond pseudonymous identities to actual identities. So what we do is we're building a protocol, and we have a concept called private contracts. So imagine smart contracts where the inputs are not visible to everyone. So this way you could work with sensitive data and really expand the let's say the range of applications beyond just sending and receiving money. My background, I'm not a technical person. I'm on the business side of things. My co-founder, we were all at MIT, and this came from his research, which was published in 2015. And I think we're set to have our protocol out this summer.
Yeah, my name is. Whoa. My yeah, it's kind of weird. I hear myself twice. So my name is Ronan. I started the Blockchain at Berkeley organization. It was the first university ecosystem in for blockchain. We do consulting, education, and R&D. We teach a few classes at UC Berkeley, from fundamentals to development. It's all open source, and also people can come and join. We do a lot of meetups. We do some research in like stablecoin, crypto economics, some protocol and consensus level, and consulting. Our main clients are Fortune 500 companies. So we've done a lot of projects for Airbus, Qualcomm, BMW, kind of help them understand where blockchain actually makes sense, not what the big four are selling them. And then we have developers that sit down and actually build the proof of concept or the pilots and until full production. And then now today we recently launched a fund that is actually investing in privacy preserving protocols. We also agree that privacy is kind of undervalued. The information today on the public chains are all public, and I think people haven't realized that yet. There's a few companies out there that are doing chain analytics and selling this data to either like marketers, government, and etc. So I think as the user, I think we have to realize that everything we're doing on Ethereum, it's everything is transparent, and people haven't realized that. Like, so that's why we want to push privacy forward. Yeah.
Can we get this place a bit cooler? AC.
Try.
I mean, it's not here. So the sweat. Yeah.
Hey, Carlos. Oh, there you go. Thanks. He's on it. He's on it. Well, thank you for the introductions. So, as we all know, blockchain moves really quickly, right? So, in the area of tech, what areas do you find most exciting right now? Feel free to just jump in, and we can share mics. We've got two.
Specific to blockchain? Yes. Cool. Yeah, there's a lot of really cool emerging tech happening inside of blockchain right now. I think that the development of new consensus protocols is absolutely fascinating. It's like how we can decide on truth. I think it's super fundamental. Every type of currency needs one, and we're seeing more and more being developed left and right. Proof of stake, proof of work. Proof of work was the OG one. It's still holding it down. We know it works, which is great. A lot of the new ones are kind of like not battle tested yet, but especially with the emergence of Dags and like non-sequential chains and transactions, to me that's where the really exciting stuff is happening. On top of all like the privacy developments and all that good stuff that I'm sure John can tell us all about.
Would you mind giving a simple explanation of some of these terms that you just mentioned?
Yes, I can absolutely do that. So consensus algorithm, let's start high level, is how the protocol that the nodes in the network use to determine, in most cases, which transactions are valid and which transactions don't make it into the chain. So proof of work is the one that Bitcoin and Ethereum use, at least for now. It involves mining, so most of you have probably heard of that. And it uses the work that your computer puts in to be sort of your percentage of work in the network is like your percentage of the tokens that are printed every 10 minutes or 15 seconds, depending on the block time. Proof of stake is a sort of similar consensus algorithm where instead of your hash power being the determining factor in your percentage of the tokens that you get, it is your stake in the network, how much money you've got. And there's different implementations on how it works, but that's the general concept. There's a lot more coming out, like delegated proof of stake, where you can use your stake to elect a few people in order to be able to keep consensus for the whole crowd. And there's a really new one called Dags, which you've probably heard of IOTA, Ryblox, maybe Nano. And yeah.
I have a huge problem with Dags, actually.
Oh, tell me about
I
it.
really dislike Dags very deeply.
Tell me
because
about it.
financial
Totally
trading
sold on them
systems most of them are built on Dags. And you have this problem that I like to call the everybody trading Apple problem, which is where they're fine in terms of performance as long as everybody's trades are evenly distributed across the network. But when something becomes popular, like CryptoKitties or Apple, everybody suddenly wants this one thing, which means you have to be constantly reconciling that thing, which becomes a huge network bottleneck. And no one's really ever tested a network implementation of a DAG in that kind of way where you might have a bottleneck. And nobody's been able to prove to me that it can survive a really CryptoKitties type of an app yet.
Yeah, exactly. So like there's still, that's what I was saying, that most of these newer protocols, especially DAGs, are not yet battle tested. A lot of them are vulnerable to much lower threshold of attack than like proof of work takes 51% of the hash power to take over the network and validate potentially invalid transactions, double spend money, versus something like IOTA, which sort of has a 2-for-1 model. Every time you publish a transaction, you have to agree that two previous transactions are valid. So you sort of like check off those, and then you hope that people validate your transaction in return. And that one has a threshold of 33%. If you can make more than 33% of the transactions happen, then you could theoretically take over the network just like that. So we're still, it's a long ways to go, but we're right on the frontier. That's the exciting part. I don't know if that's exactly the future, but it's exciting to answer Audrey's question.
So you hate, okay, go for it.
So other exciting technologies are coming up. I know you are working on scalable proof of work, but I think Lightning is pretty exciting. So the Lightning Network is essentially allowing a user or whoever participant to stake or like bound Bitcoin, for example, and then create a channel that, let's say, me and you can now transact 1 Bitcoin between each other as much as you want, like micropayments, and then at some point we reconcile it back to the main chain, and then we can see how much is actually people have. That's like the very abstract way of explaining it, but it's much more complicated.
It's like Venmo.
Kind of like Venmo, yeah, I guess. You might have.
I love the Lightning project and think they're really cool.
Yeah. Yeah, no. So I mean, you probably can, you've done more research on that aspect than me. But I think once it's actually gonna work, and you can actually connect 2 chains together that has a lot of network effect, it's actually gonna create a double network effect. And then there's some, dApps that are building on Lightning, trying to be built on Lightning. It's very early stage, but I think this year or towards the end of the year, they're supposed to release the mainnet is out, but it's not very safe, and they don't recommend any people to use. So I think this is one interesting development that might solve a lot of problems that we see today, but it actually does have a lot of problems. Another thing that I actually found out why it's interesting recently, it's usable proof of work. So I know there is a lot of negative about it because people think it doesn't make sense. But that being said, if you can create a proof of work that then you also use it for, let's say, running AI models or something. Right now it doesn't exist, and it's very like futuristic. But there's a few big mining companies that are working on AI chips, and they think that this is where it's gonna go. So that's why I find it interesting.
Can I talk about the Lightning Network?
Yeah. Go for it. Yeah. I mean, I don't invest in them. I don't care.
Okay. I like the Lightning Network. They belong to a family of what I like to call secondary networks. So you could build the Lightning Network on top of any network. And the idea that you can break off a chunk of liquidity and make a bunch of microtransactions and then bring your liquidity back onto the network, it doesn't necessarily have to be Bitcoin. It could be anything, any network. And I think that it's really neat that they're making these secondary tooling solutions. The reason that I don't think that Lightning Network is necessarily viable for all transactions or all portfolios is that if we have a channel and I've broken off like 1 Bitcoin so that we can do stuff, and then you want to do a thing, so then I have to like break off another Bitcoin and do it with you, suddenly I've tied up all of my liquidity and I can't actually do anything anymore because I like have a side channel with you and a side channel with you and a side channel with you, and then suddenly I have no more money. So they've been experimenting with these multi-party things where like you might have a massive bundle of Bitcoins, and in exchange for a fee, you will stake your Bitcoins so that we can use them as our liquidity channel. But like starts to get really complicated, and then you're like sort of becoming a market maker. So, but the Lightning Network's cool.
But I think that's a neat idea if you're trying to do like a decentralized exchange. But building on the second layers, I think like the second layer protocols are great for basically scaling up. I don't know about your solution. I will look into it, but like it's great for scaling up the network. And I think like there are 2 different kinds of. I want to move away from transactions and go to computations, because actually transactions are computations. There are 2 different types of computations that I think we should think about. One is doing high frequency, low computing power transactions, call it like something like CryptoKitties, and then the other one is more on the one-off high computation computations, say like you want to stream a video. And I think like in those areas there are different side chain solutions. I think Plasma idea is interesting, but it has a lot of holes in it. I think just reconciling with the main chain is an issue there. I'm really interested.
How do you feel about Thunderella? Do you like it? I think it's really cool.
I haven't looked enough into it.
Okay, you should look at it. It's really
Okay.
cool. It's out of Cornell.
Okay. Is it Elaine Chain?
Yeah, it
Okay.
says
Yeah,
Elaine
okay,
Chain,
yeah,
like,
I-
The like proof of stake on top of proof of work, and then
Is-
if your Byzantine fault tolerant system breaks down, then you resolve back to proof of work.
Okay, I'm actually flying to Boston this week, so I'm gonna.
Okay,
hear her
go
speak. Yeah.
talk to her. She's really
Exactly.
cool.
Okay, awesome. So that's one cool thing, and I think another cool area is how do you in these side chains create an incentive structure where multiple people can validate different computations, and you move away from like this, like within side channels there's like a, I wouldn't call necessarily a consensus, but like how do you get into like validation that a computation that's running off the main chain is actually correct, and how can you bring it back to the main chain? I think like these are very interesting questions. Like you see interesting design principles that emerge around these things. So to me, those things are very interesting, and obviously privacy is something interesting. But I think we can come to that later.
Nice, nice. So I heard a lot more technical phrases in your three answers on top of my own. Question, yeah. So I actually want to see how much dictionarying is necessary, if that's cool. If I can ask you guys, so how many of you have been to a crypto meetup before? Nice, pretty good. Classic crowd, yeah. It's solid.
That question was more relevant like a year ago.
Yeah, I know, right?
Even if you own, doesn't mean you understand. You know? Like, you own Coinbase, it's like a thing.
Exactly.
burned by BitConnect?
You saw that awesome video.
Yeah, right. BitConnect. How many people here are engineers? Okay, solid, dude. This is sweet.
Yeah.
So, right off the bat, this is already a really, really awesome panel. Like, usually you go to the crypto panels and everyone's like, "Yes, I agree." Here, I'll mimic back something you just said. Yeah, but this is cool. We've got some contention here.
Thanks.
So I talked about Byzantine fault tolerance. Who here is down with Byzantine fault tolerance? Like, yes, maybe, no. Okay. Okay, so BFT is a traditional consensus protocol, and it is also battle tested. It has been around for a really long time, and it is the solution to what is colloquially known as the Byzantine generals problem, which is that we are the generals in an army, and we all are like mounting this campaign, and you have a platoon and you have a platoon, and we have to send messages across the battlefield to each other, but one of us might be a traitor and one of us might be trying to sabotage the battle. And how do you trade messages so that we know that the message that you get is a valid one and not a traitorous message? So this consensus protocol is a deterministic one where like you get a message, you get a message, you get a message when you vote. And when you vote, it is deterministically determined whether this transaction is going to be accepted or not accepted. So this is the backbone for systems like Raft is similar to this, and proof of stake evolves out of this idea where we all should vote on whether something is confirmed or not. And this is like completely different from the idea of proof of work, which is a probabilistic model. Yeah, go. Sweet. Go. What else?
What are we missing?
Oh, things we're excited about. Yeah. I'm really excited about all of these super solid concrete applications that I've heard being developed on. Like, there's a woman that I know who's doing securitized real estate improvements on top of Stellar, which I think is just super cool because it's something that's tangible. It's this idea of you can unlock the value of properties that are right now considered to be too risky or too low value for much of these securitized commercial real estate projects. And so instead she's doing it on a blockchain. So there are all these like beginning to be real value projects that's not just CryptoKitties, and I think that is super cool. Not that CryptoKitties isn't cool, but it's not like, real estate.
Do you know how does she interact between the physical world and the digital world, and how does she? Because I assume like she is inputting the data, so you have to trust that the data that she inputs is trustworthy.
Right. So right now it's people I believe that she should be speaking to this, not me, that the idea is that in order to register for this program and in order to be securitized and get a loan through this, that you would submit documentation which has to be verified before you can be part of the network.
Cool. That's a lot of very exciting stuff. So I'm glad you did that kind of poll because there are a lot of engineers in the room and a lot of them are thinking about building their own projects. So as they're kind of trying to figure that out, what are the most important things they should be thinking about and how should they evaluate, I don't know that anyone's going to go out and build their own chain, but if they were versus, building on top of something existing and, how to evaluate this one versus that one.
Yeah. So, being someone who's building their own chain, I would say don't. No, I'm just kidding. Yeah,
Don't try to compete.
It depends on your application, of course. If you've got a really, really amazing idea that you think would be a game changer for dApp developers out there, absolutely go and try and build a platform that solves a really strong pain point that right now you can't do with dApps. Or if you've got some new functionality that you think can make it happen. But first, do a lot of research. Make sure that there's not already a solution out there, which a lot of them are still kind of underground. We're still very, very early days in the world of dApp development. There's a lot of pain points still to be discovered. It's like when the iPhone came out, we didn't know that the killer app was going to be ride sharing for like another 10 years. And I really, really don't believe that we've discovered the killer dApp yet. So if you're trying to decide what platform to use, there's obviously things to take in consideration, like who your audience is. Is it enterprise, who's used to paying kind of transaction fees, or is it more consumer-facing, who's not used to having to pay to click the upvote button on Reddit? How much data are you using? Is it realistic to store that in a shared ledger, or are you looking for a distributed file system? It really comes down to a lot of almost nitpicky kind of little details about what your application is, and no applications are identical. You've got a lot of different options to pick from when you're building your dApp stack. You've got decentralized storage platforms, you've got your decentralized state machines, you've got decentralized compute, you've got decentralized security, you've got decentralized key management systems, et cetera, et cetera, et cetera. So depending on your use case and your application, do some research and ask questions. Coming to events like this, I think, is the most valuable thing you could probably possibly do if you're trying to build a dApp. And being able to ask questions to real people who have already done a lot of this research just makes things go a lot faster.
I'm going to put an olive branch out here and say that you should probably go talk to people that have written things on top of the Ethereum network, because it is the single largest network that has the most things written on top of it. And the resources there in terms of people that are excited to talk about Solidity, even though I don't like Solidity, is huge. And just the ability to do exactly what you said, which is be able to brain dump from somebody who's already looked in deeply into some of these problems, is really can help you get ahead of a significant amount of pain. And I like how supportive the Ethereum network is. They're really fun and they're really cool. And I think that they are going to be in it for the long haul. And I hope that someday we can create our own just as cool community around our own smart contract language, which you should also look at. It's also cool. It's called Pact. So
I'll take a different approach. I don't think that dApps are the best thing to do right now. Just because I think it's just way too early to even think about what dApps or what applications will come out of this technology. We're working with a lot of Fortune companies, and it always seems like they're trying to shoehorn existing use cases to a new technology. And they don't really understand that it's like, that's not how you want to think about it. When we advise teams that come up to us and ask for their investments or ask for advice, if you have a dApp idea, let's say, for example, some proof of location that allows you to, like, everyone in the room now is going to get, $10 in the click of a button, for example. There's a few use cases you can come out of it that will be very useful in the future. But instead of building the application or the use case, try to build a protocol that allows to build many use cases on top of it. because I think like today the protocols are broken. Like most of them don't work. Ethereum like works, but like we kind of see there are a lot of problems, and it hasn't been proven that they can solve their problems. There's a huge community, large developer community, which will maybe solve these problems, or maybe we'll see Kadena solve their problems instead. You know, and like people, and yeah, and you know, it's gonna be so easy to move from Solidity to Pax, right? And I think that's what I would recommend you to like make it super easy to just steal developers from the Ethereum community.
Don't worry, we're working on it.
Yeah, you know, so and that's how you kind of steal the network effect.
What are you doing tomorrow?
Yeah, so I think like trying to figure out what protocols you can build, not application yet, because I think the protocols is something that's way more interesting. It's still early, so there's no winners. I mean, TCP/IP is not the best, but it won because it was kind of like too big to fail at some point. That everybody just threw money in it and built it. So it might be Ethereum, it might be Bitcoin, but we might see much better protocols. Like the way I say, like Bitcoin is first generation protocol, Ethereum second, and now you see like third generation that actually saw all the problems that exist and trying to solve it in a much more interesting way. So I think if you want to be in a space, like look at the protocol level right now before and find some use cases that you can sell the protocol. So like the normal people understand why you're even building it, but try to figure out like something more on a protocol level first.
Yeah, something. So, a couple of years ago, there came this famous article, "Fat Protocols and Thin Applications," and I think that kind of like misguided most of us to think that everything is a protocol, which to which I disagree. There are people who try to do, let's say, a protocol for marketplaces. To me, that's not a protocol. That is something you build on Ethereum. You use IPFS to store your data, and if in the future you want to have privacy, because like you don't know you don't want where people to know where Uber picks you up from. You need privacy, you come to us. But to us, like to me, like those are the protocol layer things. Like you don't like so I think the meaning of protocol has become a bit loose in the last year or so.
I don't think you're going to win that battle. I think people are going to steal the term protocol and use it for whatever they want because they've already stolen the term blockchain for things that aren't blockchain, like
Exactly.
IBM Hyperledger, which is using something that's totally not blockchain, but is calling it block, right?
True, but what I'm trying to get to is like building on this. Like if you have an idea to build an app, you probably don't need a protocol to build it.
Is a protocol for you?
No, it's not. It's using it's on Ethereum. Have they integrated Raiden yet?
I don't think rating is red.
So to me they're not. If you're building completely on Ethereum and you don't use any of the other components that Ethereum lacks, then you're not a protocol. But I don't want to be.
I like that you believe strongly about this.
Yeah.
I really liked Ronan's point of view because right now it is so early that there is a lot of value in protocols. At Dispatch, our first idea when I met Matt and Patrick, co-founders, so I am an artist. When I left high school, I had to pick: do I pursue music or do I pursue tech? And I've tried to keep a balance of both, and so far it's gone pretty well. But I thought it would be really, really cool if we could use this power of blockchain to take the middleman out between fans and artists. And so we sort of had this very blockchain 1.0 DApp idea of building a decentralized iTunes, more or less. So you could take out Apple, Amazon, Spotify, who takes a third to like 75% of the profits. And so we were like, all right, cool, let's do it. And we started looking around at the protocols and we were like, ooh, data, this doesn't fit with blockchain. And we found that pain point in building the DApp.
Didn't
And we sort of
Imogen
pivoted
Heap put
over.
out an album on Ethereum?
I believe you can buy the rights to the album, like sort of like buy streaming rights, like on
Okay.
Spotify or iTunes or something like that. But you don't download it off of the blockchain.
okay,
Yeah,
okay.
yeah, they're doing payments. So we realized like it's dumb to isolate them. So that's where we did exactly what Ronan's talking about. And we're like, wait a minute, this is a pain point that I bet a lot of DApp developers are facing. And so we decided to pivot more towards the protocol level. So totally agree there.
Yeah, we were focused on protocol from day one, but
Us too. It's fine.
So one thing that just came up is IBM, right? So how do you guys feel about public versus permissioned blockchains?
Go for
A lot to say.
yeah, I don't think so. Okay, permission blockchains or like federated, whatever you call them, have an element of trust, and when you have trust, you don't need what we talked about as consensus, and it becomes a shared database which to me none of the federated blockchain efforts actually, in my opinion, are true blockchain projects.
Whoa, that's really harsh because we also have a private chain that's been running for the last like year and a half. And no, that's you don't have to use it. It's fine. We have a we have a healthcare company that's using it right now to do a traditional Byzantine fault tolerant consensus protocol in with their competitors. And they are using it's this environment where it's trusted because everybody who's participating in the network, you know who they are, you had to let them in, but it's still adversarial. It's not a shared database because you don't want to give them the keys to the kingdom. Instead, you want them to sign something, put it on there, and everybody knows who did it. It has attestation. It has custody of this particular piece of information. And so that I think that there is a good use case for.
So is it more like proof of existence that this thing happened and you signed and put it there, so you have a distributed database where
I mean, it's not a distributed database because it's a
mean-
Byzantine fault tolerant blockchain system.
okay, but like
Don't
don't
what is the use case?
The idea is that we want to have a sharing of data, and when something changes, I'm going to change it and then put it onto this chain, and nobody could ever go back and modify it. Nobody who can go in and you could never change history. You could never go back and rewrite what happened. These are the problems with a distributed database, is that you could potentially go back and make modifications, but you can't make future blocks on a protocol that is Byzantine fault tolerant without rewriting history. And you can't do it.
That information is what, like, patients, like information.
We can't really like.
Well, I
we're
mean,
still
you can
under
talk in
NDA, but
general.
in general, yeah,
like,
the idea is like
where is this? So, assuming you have 7 competitors, essentially, and like, so now everybody owns the same data everywhere.
yes, it's that they get fined by the government if the data that they're using is not up to date, and the fines run into the like hundreds of millions of dollars. So everybody wants to know that everybody's using all the up to date data all the time, but they want to know who's changing it and who's making the modifications. So everybody has a vested interest in paying into this system, hosting a node, making sure that all the data is consistent. But they don't want to do like a public thing because it's just like you and your 6 buddies.
And is that, let's say I'm one of the hospitals. Is it hospitals?
Healthcare.
Okay, I'm a healthcare provider and I put data there. That data just comes from me and everyone takes it as a given, right?
Well, you have to attest that this thing is true, and then if it turns out it's not true, then you get fined.
Okay. See, to me, like more of like the blockchain concept is everyone has to be able to verify that what's coming in is true. That you don't need to have an outside attestation. But I mean,
But people put stuff into smart contracts all the time that may or may not be true.
True.
That's a problem.
That's a problem. I mean, like if you're believing in a single source of information, then like the whole idea of consensus and this like decentralized like trust to me becomes very weak. But I mean, if it serves some industries, that's perfect.
It's definitely getting used. It will continue to be used.
Well, I mean, we work with a lot of big companies. One thing that we've noticed that because now there's this thing called blockchain, it actually make big companies look internally at their internal processes and try to figure out whether it's not efficient enough. Before that, they're like, it works. I mean, it might not be efficient enough, but there's no really need to look inside and see if we can make it more efficient. And I think a lot of like the media created this like, oh, it's gonna make things cheaper, more efficient, more secure. Blockchain could be as insecure as as a database. Like it doesn't make it more secure per se. And I think that's one thing that actually allow companies to become more innovative internally to look how things work and see if there is some blockchain to be used here. Second, I think that the main net is going to be public. That's my stance. Today, there's the web and there's VPN. There's companies use internal networks to do certain things, but in order to actually communicate with the world, they have to use the web. So I think the permission ledger type of like approach allows companies to feel more confident or comfortable to kind of try this new thing without actually sharing all this information on the public. And also, the public net is not private. So a lot of companies realize, oh, we can share all this information in the public web because today we have an access, we have a wall to what we decide to share with the world. And with the blockchain, there isn't really a way today. So that's why they prefer to use the Hyperledger, like all this,
I don't think anybody prefers to use Hyperledger.
Well, I mean, it's funny because people ask us to actually build on Hyperledger. So, I mean, I think IBM did a pretty good job, like, shilling it. But, but I mean, at the end of the day, I think you'll have these private networks between kind of trusted entities or semi-trusted entities, and it's feel much more comfortable for them to use it. But once there's some privacy component integrated into mainnet, they realize that they can just use the mainnet if they need to. So that's kind of see where things are going.
Yeah, our hypothesis, because we have a smart contract language that works both in private and public on both of our projects, that we believe in this idea that you might want to create something in your private network, realize that it has a public implications, and then you can migrate it over in a fork to the public network, and that you can move back and forth from the two.
Exactly. So that's what like Quorum kind of working on. They have this kind of like public chain between everyone, but then there's like private chains between participants. So like me and you can, for example, transact with each other, so we see all this information, but like, Zane can't see what me and you are transacting, but we just like reconcile to the mainnet, and it's pretty private. Like, he doesn't really know what it is. We just like, so it's like the hybrid of public and private kind of like.
That's kind of cool. Who's doing that?
Quorum.
Quorum. We have 2 of the Quorum developers now working on our project. Yeah, we sort of ate them.
Yeah.
They're really great.
For the most part, I agree with the way that the blockchain is going to turn into like we have the general wide internet, and then we have like the private internets. But people right now, because of how early we are, have really strong opinions on private versus public, as you've heard just now. I remember when CryptoKitties was breaking Ethereum, people got so upset at CryptoKitties. They were like, why would they put something like this on the main net? They should have definitely put this on their own private thing. And people were like, what do you mean? What? It's like you're trading kitties with your friends. They're like, a public network is like a public lake. It's cool to go fishing in, but you shouldn't take a boat and drag a net, catch all the fish. So I think they're in that sense they're talking about the bandwidth and what it's called. It's a weird metaphor, but I think that goes to show the fact that right now what we're working with is so small. It's like a lake that we can all see each other in. As the technology is growing and as the networks become bigger and bigger and more capable, it's going to look much more like an ocean than a lake as it is today.
Yeah, I think like when the DARPA kind of moment today. Yeah. It's not even the web yet. Like we're trying to like figure out Netflix when we have like a dial-up mode.
I love CryptoKitties because it means that suddenly everybody's talking and thinking about scalability in a way that they weren't really thinking about before. We suddenly have to consider throughput because people actually are making things and they're popular. So I actually love CryptoKitties.
I like CryptoKitties. The CRC 721, which I think was brilliant.
Yeah, it's good.
Yeah, you want to explain it?
Yeah, so the ERC 721, most of y'all have heard of ERC 20, right? So
this is all the ICO that you invested in.
Yeah, exactly. These experienced traders here. So the ERC 20 is for fungible, and definitely correct me if I'm wrong on this, but my understanding is the ERC 20 is for fungible tokens, which means that one is worth one. They're all pretty much the same. And ERC 20, the easiest way that I think makes sense to explain, the ERC 721 is non-fungible, meaning that you still have all these unique tradable tokens, these kitties, but they're unique. They have unique identifiers, and one is not necessarily exactly always worth another in its simplest form.
Yeah, so imagine now you can put a title of the house on this token, and you always know that this is exactly this house. If you make another one, which is the same one, you realize that maybe there's something wrong, or maybe it's 2 buildings under the same address. It's like you create unique tokens for certain assets. So it can be a car, it can be a title, it can be any title. And I think for like enterprise, for example, all the supply chain that they want to do, if you can now tokenize the actual product along the supply chain, like for example, a lot of like shipping, it's still like paper. It's like paper moving from one person to another. So if you can just like tokenize it and be like, okay, I know the provenance of this paper along the supply chain from China to the U.S. Now it's like tokenizing or like digitizing this process that you couldn't do before on a mainnet. But I think it's still pretty early.
Can I ask you something? So okay, when you say you tokenize a house, you like this is someone like in the real world saying this house is mine, and gets like, maybe you get someone to some government authority to sign this. But like let's say you're doing supply chain, you're doing a T-shirt, like I'm the one who produced it. Here are the like the materials. No one gets to really check that, and then that kind of like progresses. Yeah, so my problem is, and I think like this is what a lot of people are missing. If you're trying to bring outside information, like real world information, to this blockchain world, then there's this big problem of like if like what is truth, right? Like how can you really manipulate it to what extent this is called an oracle problem, but to what extent can you trust this data that's coming in? And one of the reasons why I think that like a lot of people think about how to, as you mentioned, we're in such early days. A lot of people are trying to think how they can retrofit current ideas into the blockchain world, but there is this big disconnect between the real world and the blockchain world. And unless you are willing to trust someone with the ultimate truth, then and in my opinion, it's a bad idea. Then it's a limitation.
I agree. By the way, I think
Cool.
there's a problem between when you try to connect the physical world and the digital world, there is a trust problem, and you can try to distribute the trust between, let's say, for example, a bunch of auditors, and if they all sign it and then it becomes on a blockchain, you say, okay, like 10 auditors said it's true, probabilistically it's probably true, but there is a big disconnection. That's why Bitcoin is fine, because it's all stay within the digital world. But then like Ethereum oracles, you trust Bloomberg website, like if someone's scraping the Bloomberg website and put the data of a stock, for example, into a smart contract. So you have to trust that Bloomberg didn't mess up the quote. So there is a trust issue when you try to input physical data into the digital data, like world, essentially.
So the reason I think it's not that big of a problem is because we already have all this infrastructure in the real world built around trust. I can claim that my house is mine because I know if someone else tries to take it from me, I can take them to court. And I have trust in this system that will get them out of my house. I think a lot of the trust on the blockchain will come once we've got identity on the blockchain. Because once we can hold people accountable for the things that they're inputting, then we're going to have a lot of this existing infrastructure all of a sudden be able to apply. So I can actually hold my deed on the blockchain instead of having it on here. And that's just a distribution of private keys problem. Nobody knows how to deal with private keys yet, but we're getting there. Slowly but surely, thanks to money.
I actually surprisingly agree with you on this one.
Oh, look at that. We're some friends.
I know, right? That I believe that right now, and I'm not sure if we're ever going to move away from this, that smart contracts are not contracts. They are for enforcement. Smart contracts are for enforcing something you have already decided is true. And right now we use the blockchain for, like, we enter into a smart contract and you know that you can't violate that because math. But the fact that we entered into a smart contract in the first place, like, we had to agree to those terms. And the agreement in a contract that happens outside the world of the blockchain and becomes some sort of an oracle input is not necessarily related in any way to whether or not it can be enforced or can't be enforced. So I actually think the term smart contract is totally misleading because it's not a contract at all. It's just an enforcement of an existing contract.
Cool. Love all the dynamic, going back and forth here. So we've already kind of alluded to this already, but privacy, kind of a big deal, right? And I think y'all have more opinions on this. So who wants to kick it off?
Privacy.
So I think privacy becomes really interesting. What we think is, I kind of alluded to this. Right now, we all have our addresses. There are a lot of people who really criticize this technology, saying you're never going to have your entire bank account visible. And I think as we move forward, you're going to have, like, let's say you're playing decentralized poker, you're going to have an address for that. You're doing some sort of lending on chain, you're going to have a different address for that. You're going to have 5 different addresses across 5 different chains. One thing that we're really excited about is how can you actually bring those addresses together prove that you own them. And once you bring all this information in a privacy preserving way, what kind of value you can create. I think privacy is, I mean, scalability is the most important thing. I'm not gonna lie because I'm not working on this, but I think for blockchain to get real use, privacy is absolutely necessary because um, when there's identities, there's some trust, and there's ways of holding people more accountable. So we're super excited to be working on this. And like, if any of you is interested in like what we're doing from a more technical perspective, I'm happy to take questions after.
Do you guys use ZK Snarks to enforce privacy?
No, we don't. So we are so ZK snarks are good to verify something once, and once that's a fact that's verified, you can like make sure that is correct. But it gets really limited when you want to do like general purpose computation. We're using something called secure multi-party computation, which is but it also has a ton of limitations. The idea is you distribute data across, let's say, the entire room, and unless everyone colludes, that you cannot reconstruct my data, and then we can do any kind of computation on it. But the problem with, I should cut maybe. The problem with cryptographic encryption, I'm sorry, software encryption is it's super slow. So we're both building MPC, but we're also using Intel SGX, which is trusted execution environment, where there's trust in not the node, but in Intel. But that way you can run very scalable private computations, and we think that's a good trade-off.
I love secure multi-party computation.
Thank you.
I love it so much. I tell people that if the whole bubble goes bust and we get nothing out of all of the crypto wave other than secure multi-party computation, it's going to be worth it. Because I think that it's going to be huge.
That existed
Huge.
before, though. I mean,
Yes,
it's
it's been
not
around for
created
20
because
years.
of the blockchain space.
Yeah, but not in like such of a wide adoption, wide scale, people knowing what it is, really making good use cases out of it.
So like MPC is essentially, let's say we all have our salaries, right? Like just like an abstracted away a little bit. So we have our salary and we want to know who has the highest salary out of everyone without actually revealing who has the highest salary. So essentially we typically in the ideal world, we'll use Audrey. We each one of them give her the amount that each one of us have, and then she'll just tell us what's the highest price. So then like who is the high salary? And then the person that's his salary, he knows that he is the highest one. Then in the real world, if you don't have that third party that can be that trust, you essentially have this like function that allows you to correct me if I'm wrong, essentially prove the function in the same way but without that third party. So you have this function and then you output the highest one out of everyone, and then you actually don't have to reveal your input essentially. So that's like an abstract of secure
you can
multi.
find the solution without having to reveal your work. Basically, you can. I like to use the analogy of Where's Waldo, where you have the picture book, and somewhere everybody's trying to find Waldo. You can reveal Waldo's face to prove that you found him, but you don't have to reveal the rest of the picture to show where Waldo actually is.
Yeah, and you do it by, let's say, and I mean, so you do it essentially. So that's also what they do. They also explain zero knowledge proofs. That's also they use Waldo. So essentially, you have the picture, and then you have like a long, let's say, just white, and you make like a small hole where Waldo is, and you just give it to someone else. So you can just like move it around until you find Waldo, but you actually didn't tell him where Waldo was.
Yeah, private computations are fascinating.
Yes, I think privacy is extremely important. Like I think I mentioned earlier, if I know your Ethereum address, I know what ICO you invested in, whether you're addicted to CryptoKitties or not, like, how how much net worth you have, right? And if you think about it in the real world, if you give me your bank account, I know nothing beyond just that number, right? And I think slowly people realize that, one time I invested with my friend, and then he came up to me, he's like, oh, look how many like Ether do you have? And I was like, how, like, I didn't realize, how does he know? And then I was like, it's all Etherscan, like, you literally can see everything I have. And it's kind of concerning, because I think, like, if you ask most people here, it's like, can you tell me each one how much money you have in your bank account? Like, 99% wouldn't. And I actually met someone that said, yeah, I don't care, I'll tell you, And I was like, okay, you're like an odd animal, Typically, you wouldn't do that, right? So yeah, I think that's like why privacy is so important for the personal level. I think from like a personal information, yeah, it's important, but we're already giving away so much today that I think people got used to it. Like Facebook, you post everything, Instagram, different websites, credit cards, it's all over, and I think people just got used to it. But then now it's all these large companies are getting hacked that steal information and like start charging your credit card like $27.24 every month because you really notice that 24.7 because it looks very casual. But that's how they're essentially like stealing identities and money from you. So I think privacy, especially in the next iteration of the internet wasn't like privacy first when we built it, and now we start using HTTPS and different like privacy component that we added later. But if we are building now the next iteration, we should just keep it in mind early on instead of just like realizing that it's too late. Yeah.
So it seems like you're really into the idea of identity verification, but then you're really into the idea of concealing your identity at all times. How do you reconcile this idea between like wanting to be trustworthy, but at the same time not wanting people to know anything about you?
So the way I think about this is, so right now most
Like Monero. Let's talk about Monero.
so I think I think one thing to consider is like right now we're mostly thinking about sending money back and forward. But I think if we like, there are people who are building decentralized lending applications. I think decentralized finance is gonna happen. And if you want to get into that, like, yes, you don't want to reveal all your transactions and all your balances, but if you want some sort of like reputation, whether it's your financial reputation or like you staking is gonna be, I think, a big thing in the future. Like your staking performance, whether you like, because like one thing most people don't realize is like these are distributed systems. If you go offline, you basically like mess up the entire network. So you don't want people go offline. So like these kind of things will become your reputation. And like there's a protocol called One Protocol. If I'm a whale, I can pay someone my excess Ethereum and they could stake it for me for a fee. It's like, so a lot of this reputation thing based thing is gonna come up. And I think that we're gonna move beyond just how much money I have and who I transacted with and whether I play CryptoKitty.
Yeah, well, I think identity should be revealed when you want to reveal and whatever you want to reveal, right? Like today, I have to put all my information every time I buy something online. Like, why? Why can't I just like sign something with my private key to say, yeah, this is who I am, and there's some attestation that maybe large corporation already attested that that's who I am. So the website doesn't need to know my whole information. I can decide what I'm sharing, what I'm not sharing, right? I think just like privacy shouldn't be by default, but it should be a right. That's the way I look at it.
And one thing, building on that, when you have privacy, you can choose what to share from your identity and what not to share. That's why I think it becomes very powerful.
I have this dream that someday we will all have actual ownership of our own digital data and get to choose whether or not we share it. And like, thank you to our hosts today, Google, for having us here. But I don't really want you to mine my data all the time for all the things. And if we can really get to a place where everybody does own all of their personal data, and yeah, maybe I can choose to give my data to YouTube instead of paying a subscription fee every month, but that should be my choice.
Okay.
GRPD. Yeah, actually, that European Union movement, the GRPD, GDPR. Thank you. Sorry. Yeah, it's F7Q. No, that's actually becoming a really, really big question for a lot of people in Europe, especially people focused on blockchain in Europe. I was fortunate enough to go to Davos, Switzerland for this past World Economic Forum, and we at the Bureau helped co-host this event, Crypto HQ, that was on the promenade outside of the main event, where we had representatives from the European Union come and ask us questions. They got up on stage, and we thought they were going to present something, and they're like, we need you to tell us what sensible policy looks like. And this whole blockchain thing is crazy. It's moving 1 million miles an hour. Does it fall under the jurisdiction of these new regulations? And how can we work with the people making the technology to try and make sure that consumers are protected in the way that you dream they can be, Monica? Yeah.
Well, cool. Thank you so much. That is the time we have for the panel. So if I could just get a round of applause for everyone on here. And well, here's the exciting part. So, both of you mentioned you should talk to people who've spent hours and hours looking into this to like try to, get what they know, right? So now you get to interact with these awesome panelists in small groups. So if we could get 2 circles here and 2 circles here, and each of you take a circle, we'll be chatting for about like 25 minutes or so. And then each circle must nominate a spokesperson for them to come up at the end and share with everybody what your circle learned. So go for it. Thank you so much, guys, for coming up here. The mic is yours.
I am in the group with Zane, right? Who worked, just FYI, on Dispatch Labs, right? Which we didn't get to talk about it too much, but it tries to abstract or create a solution for data-intensive applications, and it tries to guarantee some aspects in terms of its rival IPFS. So it's trying to be a better IPFS with better incentivization. Okay. Sorry. All right. So in this group, we talked mostly about consensuses and just the basic building blocks. So we went back and looked at proof of work. What does that mean? And how exactly does proof of work reach consensus? I think this is a topic that a lot of people kind of skim over a little bit, but a lot of it has to do with the details. So a case that we just talked through was really simply multisig. What happens if you want to enforce a real world idea, which is, somebody wants to sell me a diamond. Let's say Alice wants to sell Bob a diamond. If Alice ships a fake diamond to Bob, how does Bob make sure that Alice doesn't get the funds? And without going too much into it, that's kind of multi-sig in a nutshell, and you can read about it via Bitcoins. Other proofs for consensus that we talked about were proof of stake, and specifically federated proof of stake, which is what Ethereum seems to be moving toward, which is specifically you take a subset of people in the network who have the highest worth. You trust that they have trustworthy actions because they have an incentive to keep the network going and make themselves most trustworthy. And so what you have is that's kind of, it's not been battle tested, but that's kind of the proof of stake that some new cryptocurrencies are adopting. And then the last topic we talked about was, I think it's called the signal or the gossip protocol, where what you're trying to do is solve the Byzantine generals problem by sending a series of gossip messages that are not necessarily trustworthy, but which have guaranteed arrival. And once they arrive in every general's notes, every general has to be trusted to have a common way to sort through all these messages and reduce them to one source of truth. And so that's kind of the new. That's in a nutshell what the gossip protocol is. Again, I haven't done too much reading about it, but it's a Googleable term. So, and that's about it.
Can you hear me? Yeah. Our group, our panelist was Monica from Kadena. And we had a bunch of variety of different questions, not on a single topic, but one of the topics was performance. But questions varied from, we learned, first of all, like how can you spot an MBA in a group? Like they would say, I would like to build on that. And that's like if Waldo had an MBA, that's how you can spot him. Some of the questions about blockchain involved money laundering and what is the responsibility of a developer. And Monica was like in the opinion that it's not really the responsibility of the developer, but if you're passionate about certain ethical issues or any kind of issues like that you think they're currently broken, definitely as a citizen you should volunteer your time and effort towards those. We had a question about trust in real world, whether when somebody says like, oh, this is how much I make, and you make a multi-party communication about it and you try to prove it, but how do you know whether information is true in the real world? And that's currently something blockchain doesn't provide the solution yet for. So we also talked a bit about Kadena and some of the cool tech that they're building. They have some great stuff like performance. They can do apparently 10,000 transactions per second, so that's quite a lot. But it's still less than Visa. How many transactions Visa does, but it can Kadena can scale forever. So yeah, is that not true? Okay. Um, and some of the advantages they have like multiple blockchains, and so they could do use them for load balancing when, let's say, if you have the new CryptoKitty, it can be in a certain blockchain or number of blockchains, so then you can isolate performance issues. We also learn about why they use Lisp and that's to actually constrain the basic set of instructions I think that their virtual machine can execute in order to protect the developers from writing for loops that keep depleting their Ethereum or other things, other currency. So other things like that can be solved at the language level. Yeah, that's all I can remember.
So, wow. So in my group, we talked mostly about regulations. We pretty much bombard them with questions about how how our government's gonna come at in crypto, um, because we've seen a lot of scams and people using the argument of privacy to do things like child pornography and all these things. So governments are against that. So it's finding that equilibrium between the innovation and the doing what's right for investors and people. um, and also we talked about uh, the equilibrium between scalability and security and privacy. The more scalable it is, probably the least privacy or the less private, less secure it is. So this is obviously a very interesting topic right now. So that's what I remember mostly. So thanks.
So I'm with Ronan's group. We started off with talking about trust. Trust was, mentioned to be subjective, but by default, people trust people. But when I think we were talking about that there is no right answer for finding out whether there is when there are adversarial behaviors that's on the network or when there's an attack on the network. I think trust is going to be challenged quite a bit. I think all of us going to know that. Also, there was an example about storing gold. Digix is kind of doing that, where they have three different parties to sign: an auditor, custodian, and an admin, or sort of like a bank. That's a really good example of a real-world transaction that's being digitized in a blockchain world. And also talked about Tether, where USDT had $20 million missing, right? So like when they were questioning that, like they were like finding out that there wasn't an auditor in the equation. So yeah, so and then I think there was a question about the trends of blockchain. Um, there were use cases around licensing software. That's kind of on the legal use cases. There talks about supply chain. Also very similar to Monica's group, where we're expressing the concerns about the connections from the real world and how does that tie to the blockchain world. Then the conversation went to the credit based economy for the unbanked borrowers, where there's a challenge there because folks in the unbanked world are usually not tech savvy, and there will be like onboarding issues. this concept is interesting because how do you build a reputation model from a set of group of people that are first technologically challenged, and second, they don't have a way to prove their reputation in any ways. And then a couple of use cases where Bloom and Libra is trying to solve the problem through staking and lending, I guess. Also, I didn't catch the full conversation about the Stanford effort, where there were skeptics on how do you break blockchain, and if there's a way to make money off of a concentrated place, why not? Somebody's going to cheat on it. And my ad lib to this is that like the recent hacks on exchanges, there's just so much money on exchanges. I think there's a lot of incentives for people to try to break the exchanges and make money off of it. And we've already seen use cases like every 6 months out of that. Unfortunately. And also the last one is about the new investment models. What are problems around it? I think the current ICO model is pretty broken because there's a romantic relationship between a utility token and investor token. There's no solve for this because there should be a way for investors to be incentivized to keep the investments of the tokens, maybe through payment of dividends or some kind of returns through equity play, versus the consumer token where people are actually incentivized to use the tokens for whatever that was advertised that the blockchain was advertised for. I think we covered all that.
Well, that's it. Thanks for coming out, and we'll see you next time for Marketing, PR, Biz Dev Partnerships.
Before we go, let's give Audrey a round of applause.